Hey guys, so today we're looking at lesson 20, session 1, and that's 465 through page 468. So I want you to try these problems first and then go ahead and pause and then come back and we'll work them out together. All right, number 1, the equal sign in an equation shows that the expression on the left side has the same value as the expression on the right side. A bar model can represent the relationship between the two sides of an equation. Circle each equation that the bar model represents. So all we're really doing is using our fact families. So 4 plus 3 equals 7. So 4 and 3 equals 7. Yep, represents that. What about 7 plus 4? Does it show that it equals 11? No. All right, we don't have an 11 anywhere on here. So 4 equals 12 divided by 3? No. 7 equals 3 plus 4? Yeah. About 3 times 4 equals 12. Nah. 7, take away 4, you're left with 3. Yeah. What about 4 equals 7 minus 3? 7 minus 3, 4. Yeah. What about 7 divided by 4 equals 1 3/4? No. So all this is fact families. Make sure you write that on your page too so you can remember it. Fact families. Okay. Number 2, write 2 different equations that each bar model represents. So we could say 12, so we're taking our total, and we've split it up into 3 sections. Well, that'd be 12 divided by 3, and each section equals 4. So 12 divided by 3 equals 4. What about 3 sections with 4 in each section? So 3 times 4, and that equals 12. All right, B. So we have 2 and x, so we could say 2 plus x. So 2 plus an unknown number equals 10. We could also take our total of 10, take away x, and we're left with 2. Okay, and part C, y plus y plus y plus y equals 8. Or we could say 8 divided into 4 sections equals y. All right, and go ahead and turn to page 466. Complete the model to represent each equation. So 15 equals 3 plus x. So 3 is going to be a smaller section, okay, plus an unknown number. So we don't know how many are here. So that would be x. Right, 15 divided by 3 times x. So we know that our total is 15. Okay, and then we're going to separate it into 3 sections. So 3 x's, so that would be x times x times x. Okay, number 4. An equation is true when its 2 sides have the same value. A value of a variable that makes an equation true is a solution of the equation. Use your models from problem 3 to find a solution of each equation. So 15 equals 3 plus x. So 3 plus what equals 15? So my model shows, make sure you write this out because it does say explain your reasoning. So my model shows that x equals 15 minus 3, or 12, because we know 3 plus 12 is 15. So when x equals 12, both sides of the equation (15 equals 3 plus x) have the same value. So 3 plus x, so we said x equals 12, that's 15, so that would be 15 equals 15. So they have the same value, 15. Okay, so B. So 3 times what equals 15? So X equals what? Equals 5. Right, we could also say we've got to isolate our variable, so we divide by 3. Cancels out what we do to one side, got to do the other. 15 divided by 3 is 5. Bring your equal sign, you get X, so X equals 5. So we've got to explain our reasoning. So my model shows that X equals 15 divided by 3 or 5. So since 15 divided by 3 is 5. So when X equals 5, both sides of the equation have the same value of 15. All right, number 5, reflect. Explain what the equation 3x equals 6 without using the word equal. So explain what 3x equals 6 means without using the word equal. Explain why 2 is the solution of the equation. So it means 3x has the same value as 6. The number 2 is a solution of the equation because when x equals 2, the value of the expression 3x is 3. 3 times 2 equals 6. Since both sides of the equation have the value six, then 2 is a solution of the equation. All right, go ahead and turn to the next page, page 467. So this would be lesson 20, session 1 homework, so 467 and 468. So think about what you know about expressions. Fill in each box. Use words, numbers, and pictures. Show as many ideas as you can. So let's start with our own words. So you need to try this on your own first, and then come back. We can do it together. So in your own words, what do equivalent expressions mean? So what are equivalent expressions? So they are 2 or more expressions that always have the same value. Remember, equivalent means equal. Okay? So my illustrations, like we did earlier, we can draw a box. I'm going to do 12 plus 2m. Okay? So I want to show the 12 and 2m. Well, what makes 12? 2 6s. What makes 2m? 2 m's. Okay, and then another example. Your examples may not look like mine. All right, so I'm going to do 2 times 6 plus m. So I have 6 and m. Then I have 6 and m. So 6 plus m. And there's 2 of them. Look at that. So 6 plus m here. Then I have a 6 plus m here. And if I actually work this out, so 2 times 6, use distributive property, I get 12. Bring down my sign, 2 times m gives me 2m. Look at that. They're equivalent expressions. Or an example. So 2 plus 3 and 5. They're equivalent expressions. 3 times 4 equals 2 times 6, which also equals 12 times 1. 1/2 times x is equal to x divided by 2. Remember, multiplying by 1/2 is the same as dividing by 2. Right? Next we have 2 times the sum of x and 1 is the same as 2x plus 2 if you use distributive property. Also is equal to x plus 1 plus 1. 2x plus 2. And we also have 4 plus 1 is equal to 11 minus 6. Okay, so non-examples. So what would not be an example? 2 plus 3 and 6. Not equivalent. All right. 6 divided by 2 and 2 divided by 6. Not equivalent. 2/3 and 3/2. Not equivalent. 3 times x plus 2 and 3x plus 2 are not equivalent. X minus 4 and 4 minus x. Not equivalent. All right, number 2. Circle all the expressions that are equivalent to 24. 3 times 6, that's 18. So nope. 6 times 4, 24. So yep. 2 plus 12, that's 14. Nope. 10 plus 4 is 24. Yep. 48 divided by 2. Yep, that's 24. 48 divided by 2. Yep, that's 24. Those are equivalent expressions too. Okay, 30 minus 8. No. 8 plus 8 plus 4. No. 4 times 12. No. 12 times the sum of 4 and 4. No. All right, go ahead and turn to the back. Page 468. All right, we need to complete problems 3 through 5. So go ahead and pause here and try those on your own, and then come back and we will try them together. All right. So number 3, the egg carton has brown eggs and white eggs. The models represent 2 ways of showing the total number of eggs. Write 2 different equations that could represent each model. So we could say that 7 plus 5 equals 12. We could also say that 12 minus 5 equals 7. All right, B, we could say that x plus x plus x plus x equals 12. We could also say that 12 divided into 4 sections equals x in each section. All right, and then number 4, complete the model to represent each equation. So 21 equals 7 plus x. So go ahead and pause here and try it, and then come back and we'll do it on our own. We'll do it together. All right, so we take 21, and then we get 7 in one section plus x. Remember, we don't know what x is. Right, and then B, 21 equals 7 times x. So there should be 7 x's. So I need 7 sections if my total is 21. All right, and number 5, use your model from problem 4a, so this top one, to find a solution of the equation 21 equals 7 plus x, and explain your reasoning. So 7 plus what gives you 21? So my model shows that x equals 21 minus 7 for 14. And when x equals 14, both sides of the equation (21 equals 7 plus x), so both sides, the value 21. Because of 7 plus x and x equals 14, 7 plus 14 equals 21, so they would be equivalent. Right, and that's the end of session 1.